the stuff that we've been dealing with for the last few days, we're going to put it all together. That's really what we're going after here today. Okay, so let's just dive into this. Write the equation of the line that would double the slope of f of x equals 2x plus 1 and reflect it over the y-axis. Okay, so we have two things at play here. First is that it's going to double the slope. Okay, well, what is the slope of this line? It's 2. It's always in front of the x, so we're doubling that. So it means multiply by 2. So our slope is now going to be 4. Let's see, g of x for our new equation. G of x equals 4x. They didn't say anything about shifting it, so it's going to be a plus 1 there. But then we also reflect over the x-axis. Well, reflections, we said, all it does is it changes the sign. Changes this from a positive 4 to a negative 4. So there's our equation for that. Two, write the equation of the line that would shift f of x equals x up 5 units. Okay, so this is actually our parent function. You got to remember that, parent function. Okay, so it automatically goes to the origin. So it's like it has a plus 0 right there. So we want to go up 5 units. So we're going to increase that y-intercept by 5. That's where shifting comes in. And so our new equation will be g of x equals x plus 5. All right, so we're going to put those two, we talked about this yesterday, 2 days ago, and so we're going to put that together. And so here's the table that will sum all this up. Often there are multiple transformations on functions. In order to determine the transformations, check to see if, 1, there's a change in the sign of m. Okay, so I often show something like plus going to plus. So if there's a change in the sign, if it's going from positive to negative, negative to positive, that's a change in the sign, so it is a reflection. So, for instance, if we have from plus to minus, that would be a reflection, or minus to plus, either one of those two. The slope, the value of m, has increased or decreased, flatter or steeper. All right, and then the value of b has changed. Okay, it's changed. So if it goes up, then it's shifted up. If it goes down, it's shifted down. Those are the 3 things you have to check. The only 3 things you have to check. Okay, so let's just dive into one of these. So graph f of x and g of x, then describe the transformation from the graph of f of x to the graph of g of x. Be sure to label each graph. So if I graph f of x, and I'm not going to talk you through this because we've had so much practice, we ought to be able to graph this on our own and get exactly the right thing here. So there's f of x. And then g of x, start at negative 4, slope of 2. There's g of x. All right. So if I am comparing those two, we always start with f of x. So we could say, well, first, it goes from let me just write this here, positive 3 and the y-intercept is that last one, positive 3 slope to a positive 2 slope. And the y-intercept goes from a 3 to a negative 4. So if I check for a reflection, did that change the sign there? It didn't, so there is no reflection here. Forget that. Let's see, the slope went from a 3 to a 2. So that would mean it became flatter. So f of x becomes flatter. And then we have that the y-intercept went from 3 to negative 4. So if you actually can see this, f of x becomes flatter, lays down a little bit. And then the y-intercept goes from 3 to negative 4. So it shifts down. So and shifts down by 1, 2, 3, 4, 5, 6, 7 units. f of x becomes flatter and shifts down 7 units. Okay, let's do the next one. So f of x, I'm going to start down here at -4, slope of 2. Let's see. There's f of x. G of x. Oh, I have a -2 slope there. Whoop. And there's g of x. All right, so what I'm going to compare is I started with a +2 slope. I went to a -2 slope. And my y-intercept started at -4. Now it's a -1. All right, so from plus to minus, so that is a reflection. So f of x is reflected. And we all know, we should know, that the only reflection we're talking about is across the y-axis. Okay, so flipping this way, flipping that way. Okay, so what am I doing? I'm showing you there. So flipping this way versus flipping over the x-axis, going the other way. Okay, so the only reflection we're talking about is the y-axis, so I'm just going to go ahead and say reflected. And then let's see, there isn't a steeper flatter. It doesn't become steeper or flatter. And then it goes from -4 to -1, so it is shifted actually up in this case by 3 units. Okay. All right, number 3. Let's see, we start at +2, slope of 1/2, up 1/2, up 1/2, up 1/2. Down 1 to the left 2, down 1 to the left 2. I hope it's not too terribly obvious, but I'm trying to make these as quick and painless as we can to get just kind of, they're not hard, but, you know, I don't want to spend too long talking about them. So let's see, we start at -5. Of course, you can always pause the video, go back, or slow down as you and work with me. Let's see, down 3, up, can't go down 3, so I'll go up 3 to the left 1, 3 to the left 1. Okay. So there's g of x. All right. So I know that I went from a +1/2 to a -3. And my y-intercept went from 2 to -5. By the way, I'm using this little chart here to try to organize my thoughts, to make sure I'm keeping up with all the parts we have to think about. And those actually, by the way, correlate with those 3 that you had up here. Okay, so from positive to negative tells us that f of x is reflected. It looks like it also became steeper. So comes steeper. And the y-intercept changed. Okay, the y-intercept went down, so it shifts down by 1, 2, 3, 4, 5, 6, 7 units. So in this case, we have all 3 of those transformations. That's the most we could have. We can only have 3 transformations total on something. All right, let's keep going. Number 4. I'm going to write my chart here. I go from +1 slope, 0 y-intercept, to a -1 slope with a 2 y-intercept. So plus to minus tells us it's reflected. X is reflected. From 1 to 1, not steeper, not flatter. From 0 to 2, shifted up by 2 units. So there's my total answer there. f of x is reflected and shifted up by 2 units. Okay. Again, I'm just going to kind of make my chart every time. So plus 1/3 to a plus 2. Y-intercept went from 3 to 1. Let's see. Positive to positive, there's not a reflection. No reflection. But from 1/3 to 2, that becomes steeper. That number went up. And then looking at the y-intercept, it went from a 3 to a 1. And so it shifts down by 2 units. Shift down by 2 units. Okay. Number 6. Write my chart over here. I go from -2 to a positive 1 slope over here. And then the y-intercept goes from a positive 2 to a positive 2. So right here, where I don't see a change at all, that means that there is no shifting at all. But from negative to positive, that tells me I have a reflection. So f of x is reflected. And then I also have from 2 to 1 right there. So that tells me that it becomes, if it gets smaller, it becomes flatter. All right, number 7. Again, I'm going to start with my chart. So from -4. Notice, by the way, I'm taking care of the negative sign right there. I only have to worry about the sign telling you if it's reflected or not. The sign doesn't really have anything to do with whether it's steeper or flatter and all that. So from -4 to positive 2, just the slopes there. And the y-intercept starts at 5 and it goes to -3. I do have to worry about the negative sign there. Notice that because the y-intercept is actually -3. That minus goes with it. Okay. So from negative to positive tells me that f of x is reflected. I have a feeling something else is going to happen. The slope went from 4 to 2. So it becomes flatter. And it shifted down from 5 to -3. So 5. So let's see, it goes down 5 and then down 3 more again. So it's down 8 units. And there it is. About as long as an answer that we're going to have. All right. Let's keep going. All right. Again with the chart, I'm going to make sure that I have my chart here. I'm going to start with -1/4. That's our slope here. And it goes to a positive 3. Okay, and then the y-intercept goes from 6 to 3. Negative to positive, reflection. F of x is reflected. Goes from 1/4 to 3. So it becomes steeper. And shifted down as we're going from 6 to 3. Shifted down by 3 units. Before anybody asks, yes, you have to have all 3 of these parts. This is the stuff. This answer is necessary. Now I'm using this to keep track of my stuff. You really don't have to have that, but I would very much encourage you to do that. But you got to have all three of those parts. Those are the, if I were grading this problem, I would be looking for reflected, steeper, shifted down by 3 units. I'd be looking for all three of those. Okay, so make sure you do all three of those. All right, let's see number 9. We've got +3 to +1. And it goes from -1 to -1. Positive does not reflect. So no reflection. I don't have to worry about that at all. Check. Taking care of that. 3 to 1 tells us that it becomes flatter. Okay. And then from -1 to -1, is that shifting up or down? Actually, neither. It's not changing at all. So f of x becomes flatter is that's our total answer right there. Okay. Number 10, we're going to continue with this florist problem. We've had a problem like this for the last 2 days. A florist charges $25 for a vase plus $4.50 for each flower. The total charge for the vase and flowers is given by the function f of x equals 450x plus 25. How will the graph change if the vase's cost is raised by 15%? Make sure I get all these out here. The vase's cost is raised by 15%, and the charge per flower is lowered by 60%. All right, so we really need to figure out 2 things here. So we start out, let's see, the vase's cost starts out as $25. That's the cost, the vase's cost right there. Well, it says that it's going to be raised by 15%. That means we're going to multiply that by 15%, so 0.2 or 0.15. Split by 0.15. And we get, oh, grab my calculator again. Let's see, 25 times 0.15. So this is $3.75. $3.75. So it's being raised by that much. That means the total for the vase now is $28.75. Okay, there's just one thing we need to know. Okay, now the next part of this, the charge per flower is lowered by 60%. So that means that's that 450. It's being lowered by 60%. So let me see if I can combine all this in here. So minus 60% of 450. And so that actually ends up being, so multiplying that, we get $2.70, I believe. Then we subtract that, and we get $1.80. Yeah, okay, $1.80. And that is per flower. So our new equation is we went from a positive 4.5 and a 25 for our y-intercept. We went from that to a positive 180 and a vase cost of $28.75. So I would say f of x is, let's just lay this out here, is, well, first, positive net positive doesn't change, so it's not reflected. 4.5 to 1.8, that's going to make it flatter. And it also, let's see, this is the y-intercept. It is shifted up. Shifted up by 3.75 units. In this case, it's actually $3.75. Okay. And so there, so we really were asked, how will the graph change? So this is our final answer. If you want something to box in, that's our final answer right there, the description. Okay. let's keep moving on. The number of chaperones on a field trip must include one teacher for every 4 students, plus 2 parents total. The function describing the number of chaperones for a trip of x students is f of x equals 1/4 x plus 2. This is plotted on the first graph. That's this one right here. Describe the change that occurs from this graph to the new graph. And really that is a statement, not a question. Describe this. So from here to here. Okay, so we need to be careful about this when we use these because these actually are not going by ones. That's going 1, 2, 3, 4, 5. So each one of these are 2 apiece. So 2, 4, 6, 8, 10. So, and then let's see, oh, these are going by 2s here. So that means right in the middle there, that's 3, 5. So if I were looking at my rise over run, it would be going up 1 and over 4, which is actually, we were already told this is 1/4 x plus 2. All right, now we're really worried about this new graph here. So what's the y-intercept of this right here? Now notice these are parents and students, so there are kind of some holes in our graph. You can't have half of a student, yeah, and half of your parent. That wouldn't work very well either. So we have some holes in here. So the y-intercept here is at 0. Okay, so see, and the slope, let's see, well, from here to here is 1, so up 1, and over, let's see, this is actually going by 1s here, 1, 2, 3, 4, 5, so 1, 2, 3, so it goes over 3. So my slope is 1 over 3. So when we go to compare this, I'm going to write my little chart again. It goes from a positive slope to a positive, it's going up and to the right. Goes from a 1/4 slope, and we determined it was a 1/3 over here. And the y-intercept goes from 2 to 0. All right, so positive, positive, it does not reflect, and if you look at this, you can see there's not a reflection there. 1/4 to 1/3, these are fractions, so you got to think about this. That's 0.25, 0.33. That is actually steeper. Whether you can really tell because the scale is a little off on those, this one is actually steeper than this one. So f of x becomes steeper. And we have something else here, the y-intercept. It went from 2 to 0 and is shifted down by 2 units. Okay, so it didn't ask us this, but the question really kind of that I have is, what does that mean about this graph over here? Well, the 2 right there was the number of parents that you had to have, right? The very minimum you could have. It said 2 parents total. So over here, are they requiring parents? They're not. Okay, and 1/4 told us that we needed 1 teacher for every 4 students. Over here, this means we need 1 teacher for every 3 students. Okay, so they've relaxed those restraints a little bit. Okay, let's move on to number 12. We're on our way. Okay, so compared to the parent function, describe the change in each graph. All right, so the parent function is always y equals x. So the change there, f of x is, let's see this one right. So f of x to g of x looks like it's reflected. Looks like it becomes flatter. And, well, it's not shifted at all, so n just becomes flatter. So there we are. 13. I always like to draw my parent function in here. Goes through the origin and has a slope of 1. So it goes up 1 over 1, up 1 over 1. Well, let's see. First thing I notice is that it's actually been shifted. Now, I'm not doing my little chart here, so bear with me. But first thing I notice is that it's shifted. So here's our starting place, we're going from here to here. That is shifted down by 2, 3, 4, 5, 6. 6 units. Okay, let's see. It also looks like it has become, it's actually rotated up a little, so it's steeper. Is it reflected? Nope, doesn't look like they're both going up and to the right. Up into the, you're going this way, up and to the right. So that's our answer. Okay, now 14, if I put my parent function in there again. First thing I see is reflected. F of x is reflected. Is it flatter or steeper? Well, it looks like it becomes steeper as I fall off a cliff there. Steeper. And is it shifted up or down? Look at our Y-intercepts. We've got from there to there. Let's get shifted down by 2 units. All right, we're on the home stretch. Dog sitting service charges a daily rate plus a base fee. The table below shows the amount they used to charge, where D represents the number of days and C represents the total cost. They decided to keep the same daily rate but lower the base fee by $5. What is the new total cost in dollars for 9 days of dog sitting? Okay. Well, let's see. They said they're going to keep the same daily rate, right? Why don't we figure out in the old costs, remember there's the old costs here, how much it went for 9 days, because it's actually going up from it's going up by 2s here. Looks like that is up, well, if I subtract this 2, 133.50 minus 102.50, and I get 31, it looks like. So I'm going up by 31. So if I add 31 right there, I get 164.50. That number just doesn't seem quite right. Okay. Oh, it is. That number's right. Double check with another calculator. I think that one's dying. Okay, so 164.50. Now, so we kept the same daily rate. So this is their old rate for 9 days. How did this change? So they lowered the base fee by $5. So let's subtract 5 off of that. There, we're going to take the base fee off. 159.50. And that is actually the cost for 9 days of dog sitting. If you ask me in class or after school or something, I'll be more than happy to show you more than one way to do that problem. I can think of at least one more off the top of my head. But that's, I think, the most straightforward way. We're likely going to see another one of these. Okay. All right, number 16. A shop on the beach rents lounge chairs with umbrellas. It charges an hourly rate plus a base fee for the rental. Table below shows the relationship between H, the number of hours of the rental, and C, the total cost of the rental. If the shop keeps its base rate the same, but increases its hourly rate by 50 cents, what will happen to the total cost? What will the total cost be? What will be the total cost for a 6-hour rental? So let's see, we're going to keep the base fee the same, but increase the hourly rate. So I wonder what is their base fee. So let's see if we can backtrack this a little bit. Let's go back. So this is going up by 2. up by 1. So that means if we go to 1, we'd go down by 2, so we get 6. And 0 would be 4. So $4 is their base fee. So they charge $4 automatically. Okay, and then let's see this. So they keep that the same. So we still have a $4 base rate. But they increase their hourly rate by 50 cents. Now, if you notice, we actually just figured out the hourly rate. The hourly rate, the old one, is $2 per hour. $2 every hour went up. So that means our new one is $2.50. $2.50 an hour. Well, it's a 6-hour trip or a stay. So we take 6, plug it in up there. So 4 plus $2.50 times 6. 12, that's 15 plus 4, 19, which is J. Okay, 17. Musician plans to buy a guitar for $280. She originally plans to pay for the guitar in 4 months by paying $120 now and $40 per month. How will the number of monthly payments be affected if she pays $80 now and $40 a month? Well, let's see. So they started out paying $120 and $40 a month. And we're going to 80 now and $40 a month. I don't know about you, but I noticed this immediately. They're still making the same amount for the payments. So it looks like they're actually going to pay less now. So they're going to have more payments. More payments. And if you actually work this out, $80 plus $40 a month. When is that going to be $280? If we solve that, subtract 80 from both sides, divide by 40, you will get 5. So they're going to make 5 payments. Well, compared to what they started with, they were making 4. So this is one more payment. One more payment. All right, let's look at 18. All right, now 18 looks really wordy. Honestly, this is an EOC question, so we don't need everything that's in here. So we do want to read it. Okay, we don't want to skip anything, but we want to be careful about what stuff we need here. A student works 35 hours per week and spends $25 per week on transportation. His total weekly earnings can be described using the function f of x equals 35x minus 25. Now, wait a second. Those look like they just come from up here, so I don't think I really need to write that stuff down. I don't need to pay real close attention to that. Okay, so we have this function right here where x represents the amount he earns per hour. X is the amount per hour. He's thinking of reducing the number of hours he works each day from 7 to 6, giving him weekly earnings that can be described by the function g of x equals 30x minus 25. Okay, now, is any of this stuff in here really necessary? Because they told us how we can, what we're using now. We're using this now. So really, we're comparing these two right here. If he earns $14 per hour, how much less will he earn each week if he makes the change? So originally, wait a second. He's working 5 hours less is what it looks like, because this is the number of hours he works. He's working 5 hours less, but he earns $14 an hour. That's $70. And is that what they're asking? If he earns $14 per hour, how much less will he earn each week? Actually, that is the question we've got asked there. So C is it. And so they're kind of crept up on me. I didn't expect it to occur so fast. All right, 19 is our last one. Thank goodness. The function y equals negative 3x is graphed below. If the slope is multiplied by negative 1 and the y-intercept is decreased by 2, so let's see, slope multiplied by negative 1, y-intercept decreased by 2, which of the following graphs best represents this function, or the new function? So first I'm going to think about the y-intercept. The y-intercept, if it starts right here, if it goes down 2, that means it's going to be right down here, -2. I need to grab my different colors here. So it's going to, our new y-intercept should be right here at -2. So not A, possibly B, definitely not C, possibly D. Okay, just like usual, we have a 50-50 split here. Okay, so all we did, we took care of that, the y-intercept, right? The slope is multiplied by -1. Well, I'm going to kind of go back to my chart here. A negative slope, if we multiply that negative by a negative, we get a positive slope, right? All right, so we should be looking for a reflection. Should be looking for a reflection. So does that look like a reflection? Nope. How about this one? Bingo. There we are. All right. I'll leave that up there for a second. And let's get going on this.